I didn't realise my workshop air was this bad until I built this. This is WEM, Workshop Environment Monitor, a free-to-use, fully open-source project built for anyone 3D printing, soldering, or working with anything that gives off fumes in an enclosed space, whether you can smell them or not. Let me show you what it does and what it taught me about my own workshop and home. Most of us never think about air quality until something forces us to. Flux fumes have been part of soldering forever. Everyone's granddad did it without a mask, and mostly they got away with it. Rossing core flux gives off particulates and VOCs every time it touches hot metal. It's just been normalised for decades. 3D printing adds its own mix, VOCs and ultrafine particles depending on the filament. And it doesn't stop at printing. Lots of us go on to sand, glue, and spray paint the finished part, which brings a second set of fumes into the same room. There is real research into this, and a growing amount of it is now independent, not just industry funded anymore. But it's still young in the field. No single agreed testing standard as yet. Results vary by printer, filament brand, even room size, and honestly, which safe level you're measuring it against depends on who you ask, and which country's safe level they are viewing it against. This is not me saying 3D printing is going to be the new asbestos, because truthfully, I don't think it is. I'm really not trying to scare anybody, but history has given us plenty of things that we've assumed safe that turned out to need a closer look. Asbestos, talcum powder, lead in petrol, radium, PFAS chemicals like Teflon and PFOA. And let's nail it. Assumed safe by the public, that's you and me, but not all of them by the manufacturers at the time. It's that pattern exactly why I think it's worth measuring our own spaces rather than trusting that spec sheet. Let's look at formaldehyde specifically, because it's a good example. Workplace exposure limits: UK 2 parts per million, EU 0.3, 6 times stricter, USA 0.75, sat in between. Same gas, 3 very different legal answers for what counts as safe. But here's the catch: these are all workplace limits. They assume a regulated environment, controlled ventilation, limited hours, sometimes PPE. Most of us aren't using WEM in a certified workplace. We're using it at home, in a garage, a shed, a spare room. So the number that actually matters isn't the workplace one, it's the home one. The World Health Organization publishes a separate guideline for non-occupational, everyday indoor spaces at 0.08 parts per million. That's 80 parts per billion for an average over a 30-minute period. Just be aware that regulation figures are quoted in parts per million, ppm. WEM measures parts per billion, ppb, because it's working at a finer resolution to give me the accuracy I wanted. So keep in mind that 1 parts per million is 1,000 parts per billion, and here we need to see a value of 80 or less to meet the WHO guideline. Here is a 24-hour period monitoring formaldehyde. We can see at times my workshop can exceed the WHO guideline of 80 parts per billion significantly, 220 parts per billion here. I've actually caught a 260 parts per billion during the course of developing WEM. Not good. For anyone wondering if the sensors could be reading incorrectly, well, this is what outside looks like after about an hour. According to my research, formaldehyde should be lower than 20 ppb, depending on the levels of pollution. Same with TVOC. CO2 around 400 ppm, and amazingly, 3rd of August 2026 is a really warm day in the UK. So that's it. Invisible, undermeasured, and the safe number depends entirely on whether you're in a factory or in your own home, which is exactly why I decided to stop guessing and build something that could give me the detail about what I am breathing. 3D printing actually goes back a long way for me. My first 3D printer was a Malyan M150, printing ABS on a glass bed. Yes, we used to use glass. Even then, the smell in the room told me something wasn't right and I should be careful. For me, it seemed obvious. If I could smell ABS, what about the other filaments I couldn't smell? They must be emitting particles into the air too, right? I just can't smell them. From that point forward, I was always a bit wary about spending time around running 3D printers. To be fair, it wasn't one dramatic moment that led to WEM. It was years of low-level awareness building up. I wanted actual answers, not just a gut feeling every time I walked into the room. So I built WEM, something that could actually tell me, using quality sensors, giving numbers I can trust, and tuned to how I use my own workshop and to trigger when it's above my normal levels. One thing I'd genuinely like to understand from anyone watching: if there's something you think I should be measuring that I'm not, tell me. You see, TVOC is useful, but it's a bit of a catch-all. It's not a specific answer, which is why I added formaldehyde and CO2. But if you've been working in an industry where you maybe know something that's a specific risk, then I'd like to hear about it. And if you'd rather stay anonymous, there's an email on my YouTube channel about page where you can get in contact with me. That'd be great if you could. Remember that formaldehyde chart from earlier? Turns out the biggest source in my workshop isn't the printer or the solder, it's the room itself. My workshop's lined with MDF, chosen because it's strong and is great for fixing bracket stuff. But in warm weather, it is off-gassing formaldehyde well past what the World Health Organization considers safe. And it's not something I'd have ever known about without measuring it. There's no smell, there's no obvious signs in here. The fact is, without WEM, formaldehyde is just a number quietly climbing while I'm in here. So venting stopped being a nice to have and became something I actually needed to take seriously. And that's led to a couple of things I'm already building, because winter in the UK can be too cold for having the door wide open. I'm also designing a venting system for my 3D printer. Of course, with Bamboo's closed source systems, it's much harder to design venting solutions, but not impossible. Currently, it senses if my printer's own rear vent is open or closed, and then routes the ducting and controls the inline fan accordingly. Slow, just enough to cut any smell if it's pulling from inside the chamber, or faster if it's matching the printer's own vent airflow. It also senses if the printer's actually running, and WEM's already got a section built in for this data. It's not quite finished yet, but it's close, and once it's running, WEM's exactly what I will use to help fine-tune it, or even automatically change the inline fan speeds based on WEM's reading of the workshop. This project was built in a completely different way to anything I've done before. Full disclosure, about 90% of WEM's code is written by Claude AI, and I'll be honest, part of me thinks that's a real lazy way of doing a hobby project. After all, half the point of doing a hobby is doing it yourself. But as someone who learned programming back in the early 80s on a ZX81 with 1K of memory, armed with the latest weekly magazine and absolutely no internet at all, I wanted to see what was achievable in 2026 using AI properly, not just as a toy. And while it's amazing and worrying at the same time, I have to give credit where credit's due. I found using Claude Sonnet 5 on a medium thinking level, I got very few coding errors, if any at all, and it checks all knowledge bases and data sheets before writing any code, and everything it did write compiled first time. How I actually got here, and which AIs I tried first, and which ones worked and which ones didn't, that's genuinely a whole video on its own. For now, just know that this is an AI-assisted build, start to finish, including the graphics, and I wanted to make that clear to everyone watching. Power it on, and WEM works through its own boot sequence, checking with each sensor as it comes online: CO2, HCHO, just formaldehyde, TVOC, particulates, temperature and humidity. If something's not fitted, not responding, or connected incorrectly, you'll see it right here. Once everything's checked in, it drops straight into the live dashboard. No separate setup, no app, no opening your phone first. And you may have noticed that CO2 sensor wasn't found. Well, that's why it's greyed out on the display. One thing worth knowing: on the very first boot, the SGP30 TVOC sensor needs a 12-hour warm-up before its readings are calibrated. That's normal sensor behavior and not a fault. After a normal reboot, it's usually back up to speed within an hour. First full boot procedure is in the user guide on GitHub, linked on the screen in the description. This bit's one of my favourite features. You can add a small mmWave sensor, an LD2410B to be precise, which detects motion and presence, not just movement like a PIR sensor would. So when I walk into the workshop, the screen wakes up on its own and sounds the alarm. It's a small thing, but it means that the display isn't burning back like ours, and the alarm isn't beeping when nobody's in the room, and it's ready and readable the second you actually need it. But take note, if the 3D printer is in sight of the radar sensor, then this wobbling will keep the display and the beeping awake. Everything on WEM plugs into its own header. The display, the TVOC sensor, the particulate sensor, even the buzzer, all of it. You don't need to solder anything to change your setup, and you don't need to buy everything at once. Let me explain. If something's not fitted, like here, the LD2410B radar and the SCD40 CO2 sensor, WEM notices at boot up and just grays them out. Everything else keeps working normally, so you can start smaller and build up over time rather than needing the full kit on day one. So what happens if I pull the display out entirely? Still working, no screen, but WEM is still watching. That isopropyl alcohol is setting off the TVOC alarm right now. It's still alerting, still logging exactly as if the display was there. And here it is in Home Assistant. Same spike, same alarm state, all logged. The display is not doing anything the rest of the system needs. It's just a nice way to see it in the room. That's the idea behind WEM. The display is built to give you the full experience with all the sensors attached. Gauges, alarms, presence detection, all of it right there. But if you'd rather run it headless and live entirely in Home Assistant, that works just as well. The choice is basically yours. This is the real payoff with running through Home Assistant. Everything WEM sees gets logged automatically. Set a long print going, walk away, come back hours later, and the whole story is sitting there waiting for you. Temperature, humidity, VOC, CO2, formaldehyde, and particulate counts, all tracked over time, not just a live number. So you can actually see how a specific filament or a specific job changed the air in your room while you weren't even watching. This is exactly how I found the MDF problem in the first place. Not by noticing a smell, but by looking back at the history in Home Assistant and realizing that it was rising when I wasn't even printing. However you choose to run WEM, display, headless, somewhere in between, this is what you're actually building towards. Real data, over time, about a space most of us have never measured before. I want to be straight with you, guys, who this is actually for. It isn't a cheap weekend project. Between the board, the sensors, the display if you want it, Home Assistant, Raspberry Pi if you want it, it starts to add up. It's not plug and play either out of the box. Right now you're compiling, flashing your own firmware yourself. If you're comfortable with Arduino IDE, comfortable with reading documentation, comfortable with troubleshooting, if something doesn't go to plan first time, then that's genuinely the part of the deal at this stage. If you've got a decent 3D printer, you solder regularly, or you're just someone who takes their workshop or work area seriously, then this is built for exactly that person. It's not a first-time beginner's electronics project, but it's not an unreasonable stretch either if you've built something like this before. I'd rather you know now than get halfway through the guide and feel a bit misled or start buying parts and then start struggling to put it together. On support, I can help where I can, but it's remote support, and honestly, troubleshooting something like this has its real limits. I can't see your bench, I can't check your soldering with my own eyes, I can't see if you've got an open or leaking bottle of alcohol that's causing the TVOC sensor to go wild. If the community reaction is higher than I expect, then there are things that could help. You could set up a Discord server, which you can send pictures back and forth, videos that can help. Could possibly find a company that could supply the components as a proper kit, so sourcing everything isn't like a project in itself. On cost specifically, I can't really do much about that. This is built around genuine quality parts. They're not the cheapest option that happens to work. They're a deliberate choice, not something I can compromise on to hit a lower price. That's not this project. I did try some cheap SGP30 TVOC sensors, the clone type things from AliExpress, and it wasn't good. So tell me in the comments, cost aside, be honest, but cost aside, what's actually holding you back from building one of these? I'd genuinely like to know. If there's something I can do to resolve it, I will. Everything you've seen here today is here on my GitHub account under this project name here. You've got everything you might need here, all the firmware, a comprehensive user guide here, a little bit more information down here to look at. Scroll back up to the top, you've got the hardware files, so you can order the PC. from JLC PCB. In images, you've got all close-up images of anything you might want or need to buy. If we look at the ESP32, you can see that we've got details of what the correct one is you need to buy, things you need to watch out for to make sure it works. As far as I know, you've got everything here that you might possibly need. It's all open source, free to use, free to contribute in any way you wish. Enjoy. First and foremost, I built this for me. But if it's useful to you too, then that's genuinely great. But honestly, I'm not expecting a flood of contributors, pull requests into GitHub. What I would actually love to hear though is what you would like to add. Maybe comment, well, could you add this, or have you thought about adding that sensor? If nobody ever sends a pull request, that kind of comment tells me that people are actually paying attention, and that's worth a lot on its own. Okay, so there is more coming. As I hinted to earlier, there's the 3D printing venting system. There's the fully automated workshop venting system based on whatever WEM is telling us the air quality is like, and that'll save me opening the door. And there's also whatever you ask me or tell me you'd like to see coming next. If you want to see where this goes, then hit the subscribe. That's genuinely the best way to catch the next episode. But for now, it's the same workshop, it's the same me. Just now I actually know what air I'm breathing.